doing some QAQC on airborne line data. So when you first get your data, and just verifying that the survey actually meets the specifications set out for the contractor. So just to start off, you can use, I'll go to guided tours, Intrepid datasets, and EBA DVs. And then here we'll use the EBA S database. Now, if you go up to utilities and the survey distance calculator, this will bring up the Intrepid survey distance tool, which will give you some statistics about the database that you've loaded. So I'll go File and Open Input Dataset and choose the eBagula S dataset. Open that up. And I'm also going to specify the output report as well. So it's just going to be in the same directory. And I'll say survey report. Saved as a report file. Just click Save. Now I can just click Apply, and that'll output to that report file. So I'll do that now. I'll hit Apply, say message saying complete. Click OK. Then if we go into the project manager, we'll have the survey report here, and I'll open that up. We don't have the report files associated with Visual Studio Code in Windows at the moment. So what I'll do, I'll open up a new file explorer. Sorry, I'll bring this across so you can see it as well. Local disk Intrepid. It will be in, sorry, where are we? Installation. And this is the Intrepid installation. It will be in sample data, guided tours, Intrepid datasets. And we will have our EBA DBs. I'll go down to the survey report. Now, I'll also just set this to open with Visual Studio Code. So now every time I open a report file in Intrepid, it will open it with Visual Studio Code. So I've brought that up, and as you can see, it gives you a report of the different lines in the dataset, as well as some very basic statistics about it. So we've got each line. Sorry, the formatting is a bit off, but I'll bring this in. So we've got our line number, the distance of each line, and the number of gaps in each line and the distance of those gaps, as well as the start fiducial, end fiducial, and start and end X and Y coordinates. Number of lines in the survey, total length of the gaps in there, and the total distance, which I find quite useful when as doing consulting work, making sure that the survey does match up with the contracted processing line kilometers. Also really good for gridding is the average flight line spacing. So that can inform your cell size for gridding in Intrepid. But we'll close that. Oh, sorry, I've just been told Des is waiting. Sorry, one sec. I'll just admit Des. He's going to sit in. Watch it. Okay.
Sorry, just a question on the survey distance calculator. Have there been any changes to that since previous versions, or is that just the same as it's always been?
Yeah, I mean,
same as it's always been, to my knowledge. Have you used it before?
Okay, sure. Yeah, we use that as a common tool for our QAQC process at the moment. So,
okay.
Yeah, very useful for checking all the stats and that sort of thing. I was just wondering if there are any changes to it.
No, not really. Okay. So now that we've had a look at some of the stats of our survey, I'll just go back to the QAQC tasks directory. I'm going to use the survey path editor to view view our survey. So I've actually got a task file here that'll open up, if I run task file, sorry, open with task file, it'll open up the survey path editor with our eBigula database. So there we are. And we've got the raw mag signal as the color for our survey. I'm not sure if you can see it very well, but there's also each line has the line number listed next to it on each side of the line end. And there's a little arrow that indicates the flight direction along that line. So I'll just zoom in to this little bit here because you can see there's a little bit of overlap. So this particular line has been flown, and then there's been a little bit of overlap for this particular line. A little bit later, I'll go into how to manage overlapping lines like that, because obviously you only want to take data from the high quality line. So I'll go through that briefly. But if you want to check the amount of noise in the data, or how discontinuous your data is, I'll just zoom out. There are a couple of ways. In the survey path editor, there is a admittedly quite limited tool. You can show noise profile of the signal field on the lines. So if I click on this, it'll bring up a couple of different settings. I'm just going to use the defaults, but change the vertical scale in units per centimeter to 50. No more. 0.01 is too small. So this will have 50 units. It's basically just scaling down the noise amplitude that's projected on top of these lines. So I'll click OK. And now you can see there, for the most part, it looks pretty good. But across here, it has identified some noise, and along this top line as well. It's just a very, very quick, easy way to visualize where there might be some noise in your data. But I'll close this now. Oh, actually, sorry, I've got one more thing just on the path editor. I'll turn the noise profile off here. As you can see, some of our lines are quite close together. And we might want to check how much a particular line is deviating, or whether it's deviating beyond a certain threshold. So I'll go to line display, and I will go line data validation in red. Click on this. Now these numbers are extremely large, trying to capture all the data, but I'm not going to tick on this. You can choose an upper and lower bound for the signal, and anything that is not in those upper and lower bounds, it'll highlight in red. But I'm more interested in flight path deviates by more than a certain amount over a certain distance. So for this, I'm interested in flight path that deviates by more than 50 meters over a distance of, I'm going to say 1,000 meters. Click OK. And that, I think I'll just try that again. That should bring up. Sorry, just bear with me one sec. I'm just going to click OK for that. Oh, sorry, helps if you actually turn on the option. So with that, I didn't have it ticked. Of course, it's not going to show any flight paths that deviate by this if I don't choose that option. So make sure you have it ticked and click OK. Cancel this. And so this will show areas that the flight path is deviating by more than 50 meters over that specified 1,000 meters. So as you can see, there's quite a few places. But I mean, this is a useful tool when just verifying that the contractor has actually flown to the specification that you've asked. It'll be up to you to decide what your tolerances are for this sort of thing. So I'll close that. Now we'll start looking at the actual signal within the data. So I'm going to bring up my eBagula database again. So I'll click on here. And I'm going to open it in the, editing profile editor. And our signal field is the raw mag field. Now we've got a couple of different filters we can apply to our signal. First of all, I just want no filter applied, so I'll click OK. That brings up our signal in this window. But I also want to bring up a second window with our signal filtered. So I'll go File, Load Signal Field. Same raw mag we want. But this time we're going to choose the Naudi filter. So I'll click on Naudi and click OK. Tolerance is fine, but we're going to have a larger number of points that we're sampling from. So I'm going to say, for this purpose, I'm going to say 10. Click OK. As you can see, that is the Naudi filter is picking up what it considers to be a discontinuous signal in our data. So go to the next. I might actually, if I go back, I'll use this one. So I'll go to the next line. You can, I think, as I showed in my last training, you can navigate between lines, previous and next. And as you can see, there are a lot of small spikes in the data that we may want to get rid of. So what you can do is go through and manually edit them out. But if you want to smooth your data in a more automatic way, you can go to Edit and then Find. So this will be the Find and Replace condition box. Now we're going to search our profile and we're going to search the Naudi filter because this is the one that is identifying the spikes in our data. Click OK. Search domain. We're going to do this for 2742, the line we have currently selected. So I'll click on that one, click it across. It's in our selected lines, and I'll click OK. And we're just going to keep the range we have at the moment. If you're not sure what range to select, I'll just cancel this. And I'm going to click on Layout and Show Vertical Axis. Yes, this will give you an idea of the scale of the spikes here. So I'll just go back, Edit and Find again. We'll just get our Naudi filtered data. Same name, 2742. And we would like to, for our control, confirm each one at the initially, and we're going to interpolate across. So choose interpolate, click Apply. I'm not sure why these are cutting off like this, but we want to apply to the point, and we're going to go through one by one, at least initially. And you can choose Edit or Ignore for a particular point. So click Edit. You'll see as I go along, it will smooth out the data and move to the next point. So we'll go through and smooth out each one that we choose to. If you want to do it for the whole line, just click All and click Edit, and it will go across the whole line, smooth out all of the equals. Now, some of the interpolation, especially around very noisy areas, will still have spikes left in it. You can go through for a second pass, but we're not going to do that. I'm actually just going to have a look at this. This is particularly rough data, and these steps have been introduced manually just for the purposes of showing how the tool works. What I'm going to do now is click on Edit, and say if I want to smooth cut these steps out, I can go to Edit, Interpolate, and now I need to select the data that I want to interpolate across. So I select points. If I click and drag across, it'll select all the points within that range. So, and then I can click Edit, Interpolate, and it'll cut and then interpolate across that area of signal. So I can do the same for this one as well. It's just a very, very rough run through of it. So highlight and then edit and interpolate across that. Obviously, yeah, with the data you collect may not be as extreme as this case, but it's just as a purpose of demonstration. So that's roughly it for the profile editor. I'll just show a couple of very brief techniques for comparing your planned and actual survey information. So if we go back to QAQC and tasks, I've got a plan versus actual survey task file here.
Sorry to interrupt.
Yep.
I think Adam Kroll is waiting to join as well.
Sorry. Yeah.
You might
yes.
need to let him in.
Yes. Sorry about that. I'll let him in now. Sorry. I should have. Thank you for letting me know, James. Hi, Adam. Sorry.
Yeah. Hi. Sorry. I lost track of time.
No, that's okay. I'm sorry. Yeah, James informed me that you were waiting. Sorry, I didn't see you were there.
No, that's okay.
So I'm just going to open this plan versus actual survey in 3D Explorer. I can right click and I'm going to open with task. And that'll bring up our two databases. It's a bit hard to see at the moment, but they are overlain on top of each other. I'll bring up the inspector. You can see we've got our plan survey and actual survey. At the moment, they're both showing the signal from the line field, but I want to change this for the plan survey to the planned elevation, and for the actual survey to the altitude. Okay. Now this is actually, I believe, incorrectly labeled. It should be the elevation rather than altitude. But I'll choose this, and then as you can see, it's changed a little bit. I'll make this a little bit bigger as well. Now, for my plan survey, I'm just going to choose to have it grayscale. If I can find a grayscale here. And for my actual survey, pseudo color is fine, but I'm going to configure the clipping so it makes it a bit clearer. So go to here, I'll change the stretch to linear. And now I'm going to change the data clip to custom. I'm going to change this because I want to be able to identify areas of my survey that have a much higher altitude or so elevation than expected. So I'll change this to, I'm going to go, so actually I'll just double check, not in this one. I want my project manager database. So the plan survey planned elevation was 1,015 meters. So we'll come back here to our to 3D Explore, and I'll look. I'm going to go 1,015 meters. Oh, sorry, 1,015. So this will change. So our dark areas will be areas that are close to the planned elevation, but our brighter areas are areas that are more extreme elevation, so at a higher limit. And you can see here the flight got, I think it was roughly 20 meters above the planned elevation. So you can use this to determine whether, you know, I'm not sure exactly of what sort of parameters you'd request a reflight at, but you can use this to identify areas that maybe might not meet the specification. So I'll just reset view. And you can also do the same the other way. So I'll say custom. I'll go back to the data limits. I'll say custom, no, sorry, data limits, and then custom. And I'll change this to 2015. And we have the same thing with a lighter. It might actually be easier to invert, use the pseudo color inverted. So you have the same sort of thing. Areas that are lower elevation than expected are highlighted quite easily on this. But other than that, that's kind of it for the initial line database QAQC. I'm just going to bring in Reardon now, who will go through some of the gridding grid QAQC. So bear with me one sec while we swap over. Sorry, just before I go, did anyone have any questions they wanted to ask?
None from me. I think quite a few of those tools we already use. Yeah.
No problem.
It's all good.
Sorry, what was that?
All good.
All good? Good to hear it. Well, I'll get Reardon here now, and he'll do the next part of the training. So thank you for being a great audience.
Thank you. Okay, no one here yet.
Hey, how's it going, guys? Do I still need headphones today? 2 seconds. Sorry, can everyone hear me all right?
Yep,
Excellent.
you can.
Just wanted to make sure. Apologies, one moment. All right, how's it going today, everyone? I'm Rinenbaum. I think I presented to a majority of you last week. So we're looking today at quality assurance and quality control. Tim covered lines and point data before, and I'll cover the grid section. So it's a matter of looking at some visual checks to verify your data and some other ways to resample it back against your original data to compare how it was modified by the data process. A key principle here is to exploit your well-known properties of the physics in the area. So a strong statement to put through is that any and all discontinuities in a measured potential field must be an erroneous measurement or incorrect data process. And we can verify that because we know that potential fields must adhere to the Laplacian condition. They must be continuous. So any deviation away from that is going to be noise in your data, whether it's measured or put into it via a data process. The first one I'm going to demonstrate will be in 3D Explorer, as well as the grid filtering tool. So it's the use of a sun angle drape in 3D Explorer to highlight any discontinuities. Or you can use a second vertical derivative, which is even more aggressive, and it's going to highlight any edge artifacts that you might see in grid merge. So the image that you see on screen is a grid merge artifact that was shown to us, and we developed a workflow eventually for it. But it's very clear one diagonal and one vertical artifact at an overlap that was highlighted by a sun angle drape. So it's a very quick check to see if your data or your process is good or not. So we'll head into Project Manager now. Oops, sorry. Excellent. And we're looking at this peak TMI data at the moment. So what we can do is we can open it up in Visual Explorer, 3D Explorer, sorry. And this is magnetic data that we're looking at here. And if I were to open up these settings and quickly put a sun angle drape, it shows up your edges of the field or where things begin to change, but it doesn't actually show up any clear artifacts as of yet. So that's when we might want to head into the grid filtering tool and conduct a second vertical derivative. So I'll do that now by heading into filtering and grid FFT. I'll select the input data that I want. And I'll quickly just move over to a vertical derivative, and I'll make sure it's in the second degree. Oh, and I press enter and it has run rather quickly. That's okay. This image here isn't particularly useful, so instead we'll bring it into 3D Explorer. And you might be able to tell already some issues in the data, but we'll open it in 3D Explorer just to clarify those. So if I were to take this now into a sun angle drape, we begin to see a few more artifacts. And if we then take it to a cyclic color table, such as the red cycle, it's going to highlight any values that are non-zero. And that hasn't worked as intended. I do apologize. Here we are, sorry. So in these regions here, the red on screen are any non-zero values. And we do begin to see these horizontal lines appear throughout the data. And these are in fact poorly leveled tie lines. So this was a really quick way to identify whether tie lines have been correctly leveled or if they've been ignored. So this is where we would want to go back to our tie line leveling or to our gridding process where we specifically say to ignore the tie lines. And typically these tie lines here, these errors will occur when you have an intersection over an acquisition line. Yeah, so that's the first demonstration for TMI data. And if we were to compare this to the original by overlaying it, we begin to see where these tie lines actually are compared to the original data set. So I open the data set and compare it to peak TMI. Another check that I can do is just turning down the opacity so that we can compare them together. So I drop this opacity down now, a bit further. We can begin to see where these errors lie. They're in these high regions and regions where we transfer from a high to a low, but also through the underside of some of these anomalies. Anomalies. And we can see where these tie lines were. That's another check that you can do to compare data to see whether or not it makes sense or it fits the data you're looking at. We'll head over to the tasks area in the QAQC. And what we'll look is the grid using tilt angle. So this is another grid filter. It'll apply a cosine roll-off. And what this will do, will highlight any areas where the horizontal gradients aren't adhered to. So we know that the field taking the arctan and doing some processing, it has to equal 0 in a perfect scenario. That's never going to happen. So the product of this will showcase the same areas we just saw before with the tie line leveling. So this is an alternative way to see that result. So here we have the peak TMI, the tilt. And again, just in this visual window here, we can see those tie lines show up as errors once again. So that's an alternative. If you don't want to take the second vertical derivative, you can use a grid filter and a cosine roll-off in those areas. The third tool would be the gridding of the convol tool. So that here is a task called TMI QC high order curvature. So this is a check to see if the grid adheres to minimum curvature. So if I were to run this task file, we'll have a look at the result that it produced. And so to note, this tool here, the high order curvature test, is quite aggressive. Even a perfect model, if you were to take a forward model and make a synthetic field out of it, even that won't stand up to this test. It will highlight any imperfections, and our gridding process is never perfect. So the task is done, and we'll be able to see the product here called the curvature residual. So what this task has done is it's going to calculate and estimate the residual, the error away from what the minimum curvature is. So these regions here, if we open them in 3D Explorer, and push it back to another red cycle so that we can see anything that's non-zero. Yep, I clicked the wrong one. Excellent. So we can see here, the areas in black are approximately 0. So the error is quite small when passed through this filter. And instead, these areas along through the Arnhem land here, where these are a geological feature, they're a dip in the rock, are highlighted because the gridding process hasn't adhered perfectly to the minimum curvature of the area, or the data itself hasn't, because of errors in measurement and such. So that's a highlight of another one. Another more in-depth process would be to verify if you have honored your data once you have gridded it. So a way we can do that is using the data refactor tool. So after we've produced a grid, we can put it into this tool and push the values at each data point back to the original data points. So this is a way to check to see how much a gridding process has modified your value, so that you can have a bit more confidence in what the gridding process does. So to begin that step, we'll head into the gravity area, because that's where an example database exists. And we have a gridding, a survey here. It's a nice square survey. It's a bit quicker to process. So what I'll do is open up in the gridding tool, just to quickly step through this in case you haven't seen it. I'll choose to grid the free air for now. Depends on what fill you want to do, of course. I'm going to bump up the extrapolation limit, and I'm going to go into the output grid and just bump the cell size up as well, just so it's quicker and it's hasn't got holes in it. And also, I choose to fill the holes, just for your information. Important to note, we aren't doing any smoothing iterations here. If you were to do smoothing iterations, all of a sudden you're no longer honoring the original data. And even still, this is quite a complex scenario where at what level do you honor the data? There is an interpolation within a cell even, and things become quite complicated. So I run this task and it produces a grid that looks quite all right for a point data set. Bit of jaggedy edges because we're not filling out to the extrapolation limits as suitable for the data. So we have our grid that we've produced here. And I'll need to delete this old one, don't need it here. And what I can do is I can take it into the data set area and the refactor data. So I'll choose to load a reference grid data set. So this is the data that I just gridded. And I then choose to load points from a point data set. So this is the original data that we were using. So I choose to grid the free air, or load the free air into it. This is optional. This provides us a bit of color to the scenario, to the screen. So you can see the points have been loaded in, just barely visible there. The next step here is to now push the values of the grid at each location back into the point database. So I do that by saying save reference to the loaded data set. And it'll ask me, do you want to interpolate from the reference grid back to the loaded data point database? And I select yes. And then give it a suitable name. In this case, we'll call it free air 2 underscore ref out, just for the sake of the demonstration. And I press OK. So that task is now finished. And what we can do is see that in our original database, we now have a free air 2 ref out. One thing to note here is the difference between the original and the free air 2 is that there's one sample that gets kicked off. And that's because it doesn't have actually any northing or easting value put in. So it doesn't get loaded into the refactor workflow. So it removes an erroneous point that doesn't really make sense if it hasn't got a location. The next step we can do is to start looking at how a data point was honored or how closely. So we can take it into the spreadsheet editor. And I'll just quickly format these, reorder them so that we can see them a bit easier. So spreadsheet editor is our main, well, our spreadsheet editor for the time being. There is plans in the future to move it across to 3D Explorer, but it remains quite a powerful tool for your data editing and data processing, especially if you want to do a roll your own type formula. We had the free air across, and I also want to see the free air 2 at the front of our list. So by specifying here, we can see our entire display order, and then it'll put the rest just following it by default. So now we begin to see our original data here in the left column, and in the second column, we can see the data that was pulled out from our grid. And so in each, there is a slight difference on each value. And this is to do with the interpolation within a cell that I was discussing earlier. But this is a check that you can perform if you've been given a grid and you're not sure how it's been processed, and you want to compare it against the original data that you have, to see whether or not you should regrid. This is a process that you can conduct to just get a quick idea of how much the points data has been changed or honored in those scenarios. These are the workflows that I had prepared. Do I have any questions about quality assurance, quality grid that I could perhaps address now in the meantime?
I suppose say you do grid it and there is a large difference, then what do you do about it? You just try different gridding techniques or
Yes,
whatever to get the result you want.
Yeah, you would have to go back and grid it, making sure you specify the settings that you want to use. We do have an explicit on original data, but that's what I touched on before. It gets a bit complex when the data is honored in the cell and then shifted around to interpolate within the cell itself. That's because the point may not lie on the cell's centroid, so there has to be a bit of movement and translation there. And there's a way as well that a point's value is pasted to the centroid. So if the value is found to be 30 in the top left corner of a cell, when you go to grid, there is a method where we say the centroid must equal the point that's within it. So it's a matter of personal opinion and professional opinion on which one you want to do.
Yeah. Okay. And that honor the data.
Yep.
That must only be available for certain gridding techniques, right? Like there'd be something.
My understanding is yes, it has only available for certain gridding techniques. There are some I don't believe they're greatly applied to, but I would have to ask Des if he could give comment on that. If Des is listening, I'm not too sure if he is.
That's okay. It's just, yeah, I mean, something like kriging, you couldn't, if you're using kriging, you couldn't honor the data, or
sure,
it's sort of defeat the purpose, yeah.
Yeah, of the gridding techniques available in the gridding tool, I'm relatively confident all four of the gridding methods have access to the ability to orient the original data. The one that I would need to confirm on is variable density. But from what I know, with the artifacts that we see and the pimpling that we see using variable density, they are honored. That is a primary cause for those. But to what extent, I'm not too sure. Any other questions regarding quality assurance and quality control for grids? I do apologize, it was rather quick to run through. I had anticipated it to take a bit longer for myself to get through. Or if there's any other questions regarding line and point data, I may be able to address them, or I can get Tim to come back.
I was going to ask, so in Intrepid, do you guys get data sets to QC? Like, is that a job that you get given, or?
Yeah, we do provide our, when we do services, we're going to obviously take a look at our own data and have some sort of quality control. And we do provide verification on what methods we've done. Just so you can verify the methods that we have applied. We do get support questions from people who are conducting their own work as well, that we provide some quality assurance and quality control advice on as well. So that grid mode image that I showed before in the here on the screen now, that was actually a support question that came in from a user who was conducting some grid merging. So that was the initial check that we did to see what the data was like. And then from there, we did some other steps to assess why that was occurring. So we can always backtrack. So it's a bit of an iterative process of finding a problem, applying a fix, and then trying again until you reduce it. But yeah, Intrepid has experience doing so.
Okay.
So there is no more questions to be asked or asked towards Des at this point in time. And in regards to, there were some questions last week for the gridding and grid merging, as well as the grid operations. I'm still working on answering all those questions in my best possible ability. I've got them all on my desk and I'm working on them. So I'll send those through to you, Richard, and anyone else you want to have copied over on that. There was some questions regarding the IGRF and things like that.
That's great. Thanks for keeping on those.
No worries, all good. I think that'll probably about do me for today, unless anyone wants me to run through another demonstration of something they're curious about.
I'm good.
Yeah, I'm good. I can't think of anything on the top of my head now. So,
Excellent.
yeah, I think that's, it was very quick, like you said,
Yes, yeah, I
navigating
do
in
apologize
there,
for that.
but yeah.
I have been ill, and I anticipated it takes significantly longer than what I ran through it on. So I do apologize.
Yeah. No, but as long as we know the tools that you're using and all that, we can try to do it ourselves and then
Yeah.
see how we go.
So actually, that's a good point. There's one tool that I did touch on, and I'm not too sure it has been covered, the grid convolution tool. So I'll quickly just show you that GUI. It's a Java GUI that will just run a task file in the background of typical style of Intrepid. We do use our task syntax or the messaging in the background. We just make simple Java GUIs to build the instructions for it. So if I just get project manager up here, what we have is a grid convolve tool here, grid convolution under the filtering menu. And here you have the ability to construct your own kernels. So this is where obviously your filter is going to be applied or not applied. And we have a few defined preset kernels here where you can calculate the median of cells, the C norm, Gaussian, terrace, or the curvature. This curvature is the one that I touched on using that task file just before. So this is where we check if the minimum curvature has been adhered to or not in a cell, and it returns an estimate for the error residual from what it should be and what is measured or what is calculated. So this is the grid convolve tool that may not have been touched on. And there is some documentation provided online and in your install versions using this tool. Yeah, so that's the one tool that perhaps wasn't covered in training at the moment. I'm not too sure. Yeah, but these are the tools and applications that we do use. And I am currently working intermittently on the quality assurance and quality control document as I learn more myself as well. So that's something I do add to, and is published periodically on our documentation. So thank you all for listening. Obviously, if there's any more questions ever,
I do have one more question. Sorry.
Sure. No. Yep.
Yeah, it's actually to do with the flight line data examples we were looking at before. So it looks like Intrepid's got a lot of good visualization tools to look at, flight path deviations and that sort of thing. But if you did want to view it in something else like ArcGIS, is there the option to export? So for example, if you found your flight height or path or that sort of thing was deviating, just exporting those deviations as a shapefile, for example?
I don't know if I can answer that fully, but what we do have is that our data is supported in ArcGIS when you export. So if you were to take a database such as this one here, and you were to calculate a field using spreadsheet editor, that was the deviation from the planned height altitude, planned flight altitude, sorry. What you can do is you can choose to export, and you can choose your output databases. So in this case, you can do an ArcShape, with an inputs file specified. And then from here, we have the ArcShape specified, and we can specify which fields to extract. My understanding, at least. Export group by field, export general numerical field. You can export the X and Y as geodetic, or you can force a new shape for each group. So there's a number of options here in the export tool that allow you to export particular fields out to other formats that can be opened in other software. But beyond that, I'm not too knowledgeable. I don't use other softwares. I just use Intrepid here for testing and processing. So I do apologize. I can't answer more than that.
No, that's good. Thank you.
Out of curiosity, where would ArcGIS be beneficial to use for viewing, say, that example you just gave? Why would you want to view it in ArcGIS?
Well, this might be something just because we've used an older version of Intrepid in the past that didn't have as good visualization tools in it.
Yeah.
But we've typically, had like a base map in there with the satellite imagery, the digital elevation models and that sort of thing to see if what we're looking at is an artifact or if it is an actual real ground feature. Looking at, sometimes the aircraft will fly too high, and we'll need to check if there's a legitimate reason for them flying high. Is it for safety reasons? Is there something on the ground they're flying over, or have they just deviated and it's now out of spec? Things like that. So it kind of helps to have as much GIS information in one place as you can.
Sure. And when you're viewing this data, is it over a top-down map, or are we looking at a profile view of the data itself? So as a time series and signal, or is it a map type view?
Yeah, so we're looking at like spatially located information for magnetics and radiometrics normally. So myself, Yvette, and Adam typically look at that kind of data.
Sure.
And yeah, so we'd be looking at the points along lines.
Yeah. Okay. Right. Yeah. So I think that would that's definitely something possible in 3D Explorer, and obviously it's something we can definitely improve upon once we've made knowledgeable use cases. So that's very good to hear. That's useful for us. So thank you for that example. Yeah. I think that will probably conclude all today. Thank you all again for listening. I hope you have enjoyed the trainings. I believe there's a few more from our developer, Matthew, in the coming days, if I'm not mistaken. So I hope you all enjoy, and make sure you do ask us questions when you need assistance.
Yeah.
Cool. Thank you very much,
Thanks
guys.
very much.
Cheers.
Thank you
very much.
Thanks.
Thanks, bye.
Thanks. Bye.
Thank you.
Bye-bye.